Hi all, so today we are going to see how to do program for stack using arrays. So previously you would have studied about the algorithm to do this program. So we are directly moving on to the program because you can go through the algorithm that was taught in the class and you can write the algorithm. So now I am going to show you how to do a stack program. As you all know, stack is a data structure which works on the principle of last in first out principle, that is last in first out. Whatever the data that is stored last will be taken out. So there are mainly two operations that you have in stack, that is push and pop. When you push, you will insert one element into the stack, and when you pop, you will remove an element from your stack at the very top. So here in this program we are going to have a pointer named top, which will be pointing to the last element that is inserted into the stack. So I'm going to start the program here. So initially I have the editor here. I'm going to save this program, saving it in the desktop as C, and I'm naming it as stack pgm, means program.cm, saving it. That's what I've done first. And for this thing I am going to use an array to implement the stack. So we need an array with a certain size. The size of the array will be the size of that particular stack. So we are going to start the program. We start with adding the header file. Here the header file is stdio.h, and then we will have the main function void main, and I'm not declaring anything. While we do the program, whatever variables that we are using we will declare at the top. So here first thing that you need is an array, like I'm going to name the array as S. It can store maximum of 10 elements. It's just an array. And first thing that we need for a stack is the size of that particular stack. So I'm going to read the size from the user. So enter the size of the stack, which tells like what is the maximum number of elements that can be stored in the stack. So I'm just reading that element from the user and reading into a new variable called n. Ampersand n will be the size of that particular stack. So here I'm declaring n as the variable here, and now what I have is I have the total size of the stack, and we are going to show the user what are the operations that you can perform. And be very careful when you do the stack, because stack takes one element at a time. We cannot normally, when you use an array, you continuously take 10 to 20 elements at a time, but here we cannot do that. Whenever you want to insert an element, you have to go for the option called push. When you press the push button, it reads one element from the user and store it in the stack. Again, if you are pressing the push button, another element will be read from the user and it will be storing it on top of that particular stack. So last element which is stored will be the second element that you have inserted, and when we press the pop, the second element will be removed. So I'm going to have a menu. I'm doing a menu driven program here. So we need a menu here. So I'm just displaying it here. Printf, enter the menu. I'm just typing it here. Menu for stack operation. So I'm just printf. It will just display menu for the stack operation, and we have to put it in the new line. And the first operation normally in stack we do is pushing the stack elements. So I have the first menu as push and \n, and the second operation that we normally do in stack is the pop operation, that is pop, and using the /n. And third menu that I'm going to give you is, and third one, that is display operation, which is going to display the elements that is present in the stack after the pushing and the push and the pop operation. And finally it is going to ask the user to enter the operation that you need. So we know when you normally do a menu driven program, we use switch statements to do that. Enter the menu driven program. Enter the menu to not enter the menu driven, enter the option that you need. So you have three options, 1, 2 and 3, and if you press 1 it will push the element, it should push the element. If you press 2 it should push the pop, it should pop the element, and third one it will display the element. So I'm asking for the option, so you have to read the option from the user, and since you are going to read 1, 2 and 3, it's going to be an integer number, and the option I'm going to read it into a variable as ampersand opt. So I have to declare opt here. Okay, and also we know that when you study the algorithm, you initialize the initial top point. There will be a pointer called top, which will be pointing to the last element that is inserted into the stack. So here we don't have any elements in the stack, so I am going to point top as -1. Top is set as -1 here. So scanf, that is what we have the option. Now we'll start the switch statement. And you are going to pass the option here. Whatever the option that you have user give, you are going to give it through push. And my first case is going to be my first case will be push operation. So case 1. So when we all know that when you push an element, you have to first make sure that your stack is not full or not. So for checking the stack is full or not, we are going to check whether the top element, that is, we know that top is pointing to the index location, the array index location of the last element. So top, if it's equal to the size of the array or greater than or equal to the size of the array, that means the stack is full. So I have to check whether the top element is greater than or equal to n, which says like if top is greater than or equal to n, means the stack is full. Otherwise the stack is empty. Otherwise it means like you have space for adding one more element into the stack. So that is what, when you press the first option, you are going to push the element. So you have, before pushing, you have to make sure that stack is having space to read that element. For that, we are checking whether the top is greater than or equal to n. If top is greater than or equal to n, I am going to print like stack overflow. It is stack overflow. So that is what we have. It prints like stack overflow. That means there is no space for inserting the new element. So if this condition is failed, you are going to insert the element into the stack. For inserting the element, you have to read the element from the user. So printf, enter the element to be inserted into, you cannot say that inserted, you have to say like pushed into the stack, inserted into the stack. I will change this inserted, instead of inserted I will write like pushed into the stack. So that is what the next option. So we have to read the element from the user. So for that I am using the scanf statement again. We are going to use an integer stack, so %d, and then you have to read the element. So I am making that as element. So this is the element that I am going to insert. So we have to declare that as element here. So I have read the element from the user, enter the element to be pushed, the element is read from the user. Next thing that you have to do is I have to insert that element into the stack. We know that top will be pointing to the last element that is inserted. So you have to increment that top by one position, that is top plus 1. So now the top is at -1. So it will be, when you increment it, the top will become 0, and then you have to store at that particular position, that is top stack s of top equal to the element that you are going to insert. So this is what is happening. First, initially you have top as -1. So I think like I am going to press the push for the first time. So this condition will always fail, and it comes to the else part, and you are going to read the element from the user. That is, I am going to read an element like 5. And what you do is top is equal to top plus 1 means minus 1 will be incremented by 1, that becomes 0. Then s of 0 in the array s of 0, you will be storing the element. Again, if you press the push button, it comes here, it fails, it comes here, you read the second element, and again top is now 0. So it will become top becomes 1, and s of 1 you will be storing the next elements. Like that, the last element that you are inserting will be pointed by that index location, will be pointed by the variable top. So that is what is done here. So now we have inserted the elements into the stack. So once you are using the break statement, case statement, you're going to have a break, and I'm going for the case 2, and here I'm going to delete the element from the stack. That is, we know that whatever the last element that is inserted, that will be removed from your stack. So what I will do here is, first I am checking whether the stack is empty or not. So if you try to pop an element from an empty stack, there is no use. That becomes stack underflow. So I have to check whether the stack is empty or not. For that, you have to make sure that if top equal to -1 means that is there is no element in your stack. So you have to print like printf stack, we call it as underflow, stack underflow. So that is what the first thing. If this condition is failed, you can for deleting, before deleting I am going to store the element that you have in the top to a variable, so that I can print like this element was that particular element. So the stack, the last element that you have is in the top location, and you are going to store that into a variable called del element. That is whatever the element that you are going to delete, that element will be copied into this variable. So I am declaring as del element. You can give your own variable name, no problem. I am giving it like this, and what I will do is I am going to print def the element that is getting deleted is percentage %d, comma, and you have going to delete the element that is present in del element. So that is the element that we are going to delete, and we are going to decrement the top. So because once you delete one element, the top should be decremented by 1. That is top is equal to top minus 1. So the last element that you are having is deleted. Again, I am going to put a break statement here. Fine. Now we have the case 3 that is going to display the element. So we are going to display this array from 0 to the top index. So we have to go for a for loop here. For I equal to 0, I less than top, I plus plus, I plus plus, then I am going to print of the statement, print of the elements in the stack are backslash n, elements in the stack are backslash n, and I am going to, sorry, if you are putting it inside the loop, this will be repeatedly printing that there. So I am just going to print it here. Printf, you have an array, and then the array names are s of I. So since you are using a variable I, you have to declare I here, right? So that is what is happening here. So we are displaying the elements, and we are going to have a break statement which will be stopping this statement as well. And after that, I am going to put a default statement, because any other option that is given for the switch statement, you are going to print like invalid statement. So I am going to print a invalid choice. That is what the next element that you are having it here, the next choice, that is invalid choice, and that's what we have. And let's break it here. That's it. So once you are going to have this thing. So what happens here is I will run this program, and then we will do the changes. So now we have 3 options here: push, pop, display. When I press the case 1, it comes here, it will check whether the stack is full or not. If stack is not full, you are going to insert it. Or second case, if you're going to first check whether the stack is empty or not. If stack is empty, you are going to delete the element from the stack. Third option is display. So when you press the display, you are going to do that. So I am opening up my terminal. So I have saved it here. Let's wait. CD. We are moving to the desktop, and the desktop I have a folder called C lab, and in that I have saved the file as stack program. So we're compiling gcc stack dot c. So it's showing some error messages here. Let's see what are the error messages. First thing is you have to change it to int, no problem. That is just a warning. And then we have semicolon missing. Here also semicolon missing. So there are a lot of semicolon missings there. So I have a semicolon missing here. I have a semicolon missing here. I have a semicolon missing here. Here also we have a semicolon missing. Any other missings? No, that's all we have here. If you want, you can go for int. It's just warning, no issues. You can go for int main here. So let's run this program. I'm just clearing the answer. I think it can let me increase the size of this thing. Okay. GCC stack. Again, we have a semicolon missing in somewhere. So let's see that stack overflow, stack underflow. Here is the missing. Okay, now I hope it will be correct. So let's run this program. I'm running this program, and what we have is it's asking for the size of the stack. I'm going to give a stack as 5. So suddenly it comes to the menu, and we have to correct this thing because we have to put a slash in here. I'm going to first option. So it's asking the element that has to be pushed. So once I press this, it comes out of the program. So that is not what I want here. What I should do is once I press the push button, it should come back to this menu again. It'll ask it should ask whether it should ask once I press this, once the element is inserted, ask the user whether you want to continue or not. So once I want to continue, it come back to the menu. For that, I will go for a do while loop. That is, I have to do this thing because at least once this push statement should be taken, and once after the switch statement, you have to put a closing bracket, and here I am going to read something from the user, that is printf, do you want to continue, and I'm giving it bracket as you should type like yes or no. You can give any method for this thing. I'm just going for the do while loop here. That'd be easy. And then it should ask the user scarf what you are going to use. So you are going to store yes or no, that is y or n. So you can go for s to s or c. Here I'm going to go for string because the c is not accepting in my editor. So c, and I should read the variable like I'm giving it as ch. Okay, so what happens here is it will ask for the choice and do you want to continue. If I'm going to press yes, so do all these things while what I should do, while ch not equal to yes, while ch equal to yes, that's right. So whenever you give the choice as yes, it should go to the do statement again. So that is what do while loop will do. So let's see what is happening here. So I'm just clearing the statement and we'll compile this program. So I think we have to declare ch here. Yes, that is what is happening, and clearing see scan of percentage, oh sorry, it is a character element, so I should declare it as char ch. Fine, now it will be working fine. Clear. Did I save it? Just a minute, let me check what is it. Character ch, that is what we have done here. Percentage s, yes, it's working now. Now let's see the output. First thing, you are giving the size of the stack. I'm going for push and I'm going to push this. So it's asking whether you want to continue or not. I'm going to give it yes. So what happens? It comes back to the next statement. Again, I'm going to push. So I have first element that I pushed was 4 and the second element was 1. And I'm going to push again. I'm going to give it as 7. And do you want to continue? Yes. Again, I'm going to push and element I'm going to push it. So I have pushed 3 elements, right? So yes. And if I want to check, I can display this thing. So what are we displaying here? So first element was 1, element to be pushed 1. So what happens here is when you display it, you are displaying only up till 0 to top, right? You have to display up till top minus 1. So let's see. No. So when you have a display here, you have to go for top equal to top. Fine. Let's see what is happening. Yes, so I'm giving it as 3. Let's push 1, and I have element 5 pushed, and again I'm going to push another one, 8, and let's go for a display. I have 3, and I have displayed 5 and 8. So I'm going for the pop operation. I'm going to pop 2. So what happens here? The element that is getting deleted is 8, because the last element that you have inserted is 8, so that will be deleted. And if I press yes and if I display it, it will be displaying only 5. So this is how stack works. So you can, what I have done here is, I have showed you how to do the stack program here, and you have all these things you can do it. But when you do it, I suggest you to do it using functions, because I am not using functions. What you can do is, you can use these statements inside functions and try to do it using functions, and try to complete it and upload it in the classroom. And algorithm, I think Supriyam has already taught you during the class, and go through that and write the algorithm, and now see the program how it is working, and you can do this program and upload it in the classroom. And I'll be uploading the queue using array as soon as possible. Thank you guys, thank you for your time and patience.